Hello students, welcome to our student support program for grade 9 mathematics. Our topic for today is surface area. You will remember that in the previous lesson you have learned about surface area of a cylinder. And in today's lesson you will learn about surface area of a right prism. So let us start with the learning objectives of today's lesson. In this lesson, you will learn how to draw the nets of a right prism and how to find the surface area of a right prism. So what is a right prism? A right prism can be defined as a solid three-dimensional shape having a uniform cross-section. You can see in the pictures that we have different types of prism. We have a rectangular prism, which is in fact a cuboid, and you have already learned about cuboid in grade 8. Then you have a triangular prism. You also have a pentagonal prism and an hexagonal prism. Let us have a look at examples of prism in real life. You can see boxes of cereal, matchbox, chocolates, and so on. Before we continue with the lesson on prism, let us have a quick recap on the other 3D shapes which we have already learned about. So a cube, you will remember that a cube has 6 faces. It has 8 vertices and 12 edges. So a flat surface is called a face, and a cube has 6 faces. An edge is a line segment where any 2 faces meet, and where the 3 faces of the cube meet, the corner where the 3 faces meet, we call it a vertex. So a cube has 6 faces, 8 vertices, and 12 edges. Remember, we say one vertex, but many vertices. This is the picture of the net of a cube. The total surface area of a cube now, if you remember, a cube has 6 faces and each face is a square. So the area of one face of the cube will be equal to the area of a square, which is given by L square. So the surface area of a cube will be given by 6L square because we have 6 faces. Now we move on to cuboid. As I have mentioned earlier, a cuboid is also called a rectangular prism. So a cuboid will have 6 faces, 8 vertices, and 12 edges, just like a cube. However, here all the faces are not equal. This is the net of a cuboid. And the total surface area of the cuboid will be equal to the areas of the different rectangles. As you can see here, we have rectangle A, B, C, D, E, and F. But rectangle A and D are equal, rectangle B and E are equal, and rectangle C and F are equal. So the surface area will be given by 2 times area of rectangle A plus 2 times area of rectangle B plus 2 times area of rectangle C. So the formula will be surface area of cuboid equal to 2 times length times width plus 2 times length times height plus 2 times width times height. Finally, we are going to get 2 into length times width, that is L times W, plus length times height, that is L times H, plus width times height, that is W times H. We have also learned about cylinders in the previous lesson, and you will recall that this is the net of a cylinder, where we have two circles and a rectangle. The curved surface area of a cylinder is given by 2 pi r h, where r is the radius and h is the height. The total surface area of a solid cylinder will be given by 2 pi r square plus 2 pi r h, because for a solid cylinder we have a circle at the top and a circle at the bottom. Now we move on to the triangular prism. So let us have a look at this picture. We have a triangular prism here and we have the net on the right. The cross section of this prism will be a right-angled triangle. And you can see that this prism, which is found on the left, has its net on the right. So you have two triangles at both ends, and these are the two triangles here. Then you have the base of the prism, which you can see in this rectangle, and the two inclined sides are found at the ends here. So you have your net of a triangular prism. The second example here is where the cross section of a prism is an isosceles triangle. Remember, an isosceles triangle will have two sides equal and two angles equal. So you have your two triangles on the right here in the net. At the top and at the bottom, you have your two isosceles triangles. Then you have a base of your prism, which is found in the middle, and the two inclined sides are found at both ends here. So this is the net of your triangular prism. Now, you will remember that in lower grades, you have learned about area of trapezium. So the area of a trapezium is given by half sum of parallel sides times height. And in this diagram, my parallel sides are A and B. The height is h. So the formula for area of trapezium will be given by half times a plus b times h. We will use these when we are going to calculate the surface area of prisms. First example. The diagram shows a triangular prism. Part A, calculate the length of AC. Part B, draw the net of the prism. Hence, calculate the total surface area of the right triangular prism. So you can see here that we have a right angle triangle as cross section. Now, I need to find the length of AC in the first part. So first we will draw the triangle ABC. So AB is 5 centimeters, BC is 12 centimeters, and I have a right angle triangle. Do you still remember how we find the length AC in a right angle triangle? Yes, we are going to use the Pythagoras theorem. So here, AC to the square will be equal to AB to the square plus BC to the square. That is, AC to the square will be equal to 5 to the square plus 12 to the square, which is 169. So AC will be equal to square root of 169, which is 13 centimeters. Part B now, I need to draw the net of the prism. So to draw the net of the prism, we have a triangle ABC here. So we are going to draw the triangle ABC here with dimensions AB 5, BC 12 centimeters and AC 13 centimeters. We are also going to have triangle DEF here with the same dimensions. Then we have the bottom face, which is here, BCDF. So BC is going to be 12 centimeters and CD is going to be 10 centimeters, same as AE in this diagram. You can see here. Then we are going to have a rectangle ABFE. So this is the rectangle here, ABFE, with dimensions 5 for EF, 5 centimeters, and AE, 10 centimeters. And finally, we are going to have the rectangle, the inclined one, ACDE. So here is the rectangle, ACDE, with dimensions 13 centimeters and 10 centimeters. So this is going to be the net of the prism. Now I need to find the total surface area of the prism. So we are going to look at the different shapes and find the area. First, we are going to find the area of the two triangular faces. Remember, area of triangle is half times base times height. So here I'm going to have half times 12 centimeters the base times the height 5 centimeters. But because we have two triangles, so we have 2 times half times 12 times 5, which is equal to 60 centimeters square. Next, we are going to calculate area of rectangle AEDC. AEDC, this rectangle, so 13 times 10, which is equal to 130 centimeters square. Next, we are going to calculate area of rectangle AEFB. AEFB. So this is going to be equal to 5 times 10, 50 centimeters square. Next, we are left with the bottom part, that is area of rectangle BCDF, which is going to be equal to 12 times 10, that is 120 centimeters square. Now to find the total surface area, we need to add all these different areas. 60 plus 130 plus 50 plus 120, which is equal to 360 centimeters square. So the total surface area is 360 centimeters square. Now we move on to the next example. Find the total surface area of the figure given. So here you can see that we are going to have an isosceles triangle for the cross section. So to help us, the first thing that we are going to do here is to calculate this length, which I have called x. I need to find x. So again, using Pythagoras theorem, x squared will be equal to 3 to the square plus 4 to the square. So x squared will be equal to 25 and x equal to square root of 25, which is 5 centimeters. So now I know this length, 5 centimeters. I'm going to find the area of the two triangular faces. So here the area will be given by half times base. The base is 8 and the height is 3. So 2 times half times 8 times 3, which is 24 centimeters square. Then I'm going to calculate the area of this inclined side. 12 times 5 centimeters square, that is 60 centimeters square. Remember that we are going to have two identical inclined sides, one here and one on this side. Finally, area of bottom face, which is 12 times 8, 96 centimeters square. And to find the total surface area, we are going to add the area of the two triangles, 24, plus area of this inclined face, 60, plus the area of this inclined face on this side, 60, plus the bottom face, which is 96. So the total surface area will be given by 240 centimeters square. Now you have a few questions to practice on surface area of prism. First question, find the surface area of the following diagrams. So you will see that in part F, you have a trapezium as cross-section. And I have already given to you the formula for area of trapezium. So this is where you will use the formula for area of trapezium, because you have a trapezium as cross-section. Question 2. A rectangular tank of length 30 centimeters and width 20 centimeters is filled with water to a height of 14 centimeters. You need to calculate the total surface area of the tank that is in contact with the water. So in today's lesson, we have learned about the right prism, the net of the right prism, and how to calculate the surface area of a right prism. Here are some interesting links for you to get some additional practice on surface area of prism. So students, we have reached the end of today's lesson on surface area of prism. I hope that you have enjoyed this lesson. So until we meet again, it's goodbye from me.